Center for Nutrition Modeling seminars. We started this last year in January and decided, one a year is about good. And so this is actually the second installment, but this time, we're a little more prepared for this stay-at-home stuff. And so we do actually have a few different sessions lined up for quite a few months. And so keep your eyes peeled on your emails as announcements come in. And the announcements will have a link somewhere on them to a Teams meeting like this to get into. And Jen is going to keep an eye on the conversation that's going on the side. So if you've got questions during the talk, you can actually type them in on the side, and we'll bring them up at the end, and have the team discuss whatever's brought up in those questions. We're also recording the session here today, just in case we want to show it to other people in the future as, part of the activities of Center for Nutrition Modeling. And so today's lab group is Dom Bureau's, and Dom has been doing modeling for quite a while, and it wasn't something that he was trained in initially, but he just saw the value and the utility of models in the research area that he was working in. And I'm not really going to give any more introduction to that, because actually what Dom's presentation is the introduction to the various activities they're doing. And so he's got some of his associates with him. So Steve and Netta and Matthew and Flavia are here to help present what their group has been doing. And it's worldwide and international, so it's really going to be fascinating. So Dom, I'll let you get things going.
Thank you very much. I'll share my screen right now and tell me if I get started. All right, you all see my screen? That's very most common question these days.
Yep, it's good.
Yeah. All right, so I want to give an overview, like John said, of my own path through modeling and how we converted academic research into a commercial reality, or are doing so. I work in aquaculture, and when I got started in aquaculture, it was a very small industry. It was just, I got in that field out of interest because it was very neat and very new, But over the span of my career, 30 years, the aquaculture production has grown tremendously, and now it is a sizable industry. Over 70 million metric ton of farm seafood are produced every year. Asia is the main producer of these aquaculture products, but there's a number, with China being a dominant force, but there's a number of other countries that are major contributor, from India, Indonesia, Vietnam, Bangladesh. You can read the things. In the Western world, Norway and Chile are two of the major countries, but aquaculture is carried out pretty much around the world, but mostly in Asia. Interestingly, or unfortunately, Canada is very far behind many of the countries, despite our great water resource. We're only about 200,000 metric tons of aquaculture product per year, maybe give or take 50,000 metric tons. So it is actually a very small industry for Canada. Something that characterizes this sector is the diversity of it. There's literally hundreds of species being cultivated, fed species being cultivated, and it's done in all kinds of environment, from a pond in a backyard, a hole in the ground, up to a very advanced, sophisticated technology, advanced marine cage farms in the ocean bay. To support this aquaculture industry, a feed industry has grown tremendously over the past 30 years, starting with just a few million metric ton, and now we're at 41 million metric ton, maybe more if you can account for everything. It is a sizable industry, and maybe it's smaller than beef and dairy in terms of volume, but the quality of feed is so much higher. So it's a very high protein, very high fat feed produced using very advanced manufacturing technique, the same technique used in pet food manufacturing, extrusions, and the like. So actually, these feeds are produced in significant volume around the world using very advanced technology, and it's one of the cutting-edge field in actually feed manufacturing sciences. Now, when we think about aquaculture here, from our perspective as Ontarian, we're thinking about a trout farm with a raceway or a pond or tank inside a building, maybe a pond, or cages in the North Channel around Manitoulin Island or around Parry Sound area. And it is part of the aquaculture industry. It is a segment of the aquaculture industry, but the bulk of the production is either done in open water cages, these very modern marine cage for salmon, for example. This is in Chile and Norway, in the UK, on the west coast and east coast of Canada. But the bulk of it is done in ponds, in these flatland floodplains area in Asia, notably in China, but in India and Bangladesh, and places like this, where you literally see hundreds and if not thousands of ponds with different, like producing different types of species. Even in the shrimp industry, which is a higher end product, still done in pond, a little bit more technologically advanced with more aeration, more equipment, more human intervention. But it is a sizable industry, a highly technical industry that is playing an important role in the supply of food product in the world. The production environment in aquaculture is a complicated one. Imagine you're raising the fish or the shrimp in a body of water. That body of volume is several millions of liters. You have equipment moving around the water. The water can be 1 meter or 2 meter deep. It's very turbid. You can't see anything. The animals are small, quite sensitive. So there's no way you can actually count your animals. Even feeding the animal is a challenge because you're not seeing the animal per se, depending on the species. And you don't know how many animals, how big they are, unless you're sampling. And when you're sampling, you're only taking a small portion of the population. So you have no way of doing a complete sampling of your inventory. So that introduced a number of challenges from a management perspective. I work very closely with the cage culture industry here in Ontario. It is a small, we're only producing 5,000, 6,000 metric ton of trout per year. They produce a fish over a long period of time because of our water temperature fluctuation. As we all know, there's periods of this year that the fish are not growing or hardly growing. So it's a long and risky process to produce this fish. But I've been fortunate to work with this industry. It's only 8 to 10 operations, not too far away. So we were able to closely work with these operations, develop a good relationship. So although it was a very small industry and very insignificant on the global stage, actually it's been a very good partner for us because of the proximity and because it's their mom and pop's operation, basically. Now they face the same type of challenge that many other aquaculture operations are facing. Namely, it's done in the open, so you're exposed to environmental variability. You also have environmental stewardship issue because you're releasing your waste in the public domain. So you have to be careful, you have to be conscious and sustainable in the way you operate. The feed are expensive. We're talking thousands of dollars per ton, between $1,000 to $2,000 a ton of feed. So it's not cheap feed. They operate in a remote area, in rural area, sometimes offshore, which brings its own challenges. They operate in area where the labor is not very skilled, not always completely dedicated. So you have to bring workers from elsewhere. And when you hire local people, sometimes it's a little bit of an issue. And you got the whole issue that pretty much every aquaculture operation is facing is monitoring your inventory, your fish crop, how well they're doing is actually really quite challenging. And in our farms, because they're small, they actually don't have very much means to invest in the big resource that cage farms in Chile or Norway have. So they're very low tech and they have to make do with very low tech equipment. So dealing with these operations, whether they're very modern or very backwards or very kind of local, notice that they had a need for tools, precision aquaculture tools, if we want to call them, in order to forecast and manage growth and production, estimate feed requirements and manage the feeding. And I mean both for the animals and the people managing the feed. Imagine your feed is costing $1,500 a ton. You don't want your staff to waste that feed. So actually managing your staff that are feeding, looking over their shoulder is extremely important. Comparing performance. Imagine you have different temperature profile. The metabolism of the fish is determined by temperature. So your seasons, your temperature plays a role in the growth rate, your estimates of growth rate. How do you account for that? So how do you compare, compute, objectively, right, benchmark your performance is everything. Then there's a big issue of loss associated with disease and other problems, environmental losses and stuff. How do you manage the pathogen load? How do you manage the loss or predict the loss that you're going to get and minimize these loss? There's the issue of product quality. You want to tailor your product. Your market wants a product of a certain characteristics or that was fed this or not that, and etc. How do you support consumer confidence in your product? Because aquaculture is new kid on the block, because the production is done in a public domain, actually, there's quite a bit of pushback sometimes by a number of environmental groups and other interest group in order to undermine confidence of the public in this thing. So you always have a battle to try to keep confidence in your product. And then the industry have signed up with a number of certification bodies, and you have to compute sustainability metrics, things like fish in, fish out ratio and waste output per ton of fish produced, and etc., which can be actually really quite complicated to achieve, at least objectively. It's easy to do on a corner of the desk, but difficult to do well and objectively. We work with farms, and what we saw, we use models to model production, for example, and when we started contrasting our model simulation with farm data, we found some really weird things. This is what not one occurrence, but the farm was reporting much greater weight than what we were expecting the fish to be, and even greater weight than the harvest weight 2 or 3, 4 months before harvest, which didn't make any sense. We realized through the use of modeling that a lot of the farm data were actually biased. The employees were sampling fish. They were not lying. They were sampling real fish, but they were sampling the bigger fish because challenge associated with the field. Imagine trying to catch a 500 or 600 gram rainbow trout in this situation, right? Bending over a cage, right? Side of a cage when it's icy. It's extremely dangerous and things. So actually the sampling is biased. They can't sample the entire population. As soon as the fish is quite big, they're extremely difficult to catch. So we found that actually modeling was extremely useful for auditing data, identify bias in farm data, which has serious consequence. If you're managing a farm and you think your fish is 1,000 gram and they're really 700 gram, that's a big problem for feeding and estimating, right, forecasting your harvest. The other thing is because the data has to be reported sometime to a certification body or the government, then you expose yourself to releasing misleading information. And one day, the proverbial thing is going to hit the fan because somebody is going to make a big deal out of it. And it happened in Chile, and it happened in China, and it happened in other places. So it will happen. So there's real interest there should be interest in making sure that the data is not biased. Now I can show you hundreds and hundreds of slides of work that we've done with the industry, with different industry partners, from feed ingredient suppliers to feed manufacturer to aquaculture producer around the world. And I've developed these spreadsheets, and I laugh when I find these spreadsheets because I put a new name to it. So like a spreadsheet model found 2013, found in 2017, and then later lost, and because I have to keep track of things I lose. So it's been extremely valuable. I think we did some really good work. People were really happy with some of the work we did with them, but it's also very inefficient. Many years ago, we started this process of saying, well, maybe we need to develop something more systematic and more usable, using not just us doing the work, but putting out a tool that people can use. And we published a paper way back in 1998 promising a software, and we were working on it. So we presented the development model, and we were promising a software. It was a pet project of my former advisor, Professor Young Cho, and I worked closely with him on this. I had a little fun over the weekend and kind of started listing all the efforts that we were involved in over the years, the academic, and then after that, more the commercial. And I'm highlighting the academic here. Dr. Cho for many years pushed the idea of developing this Fish Perfect software. Some work, at least developing in spreadsheet this, but any effort to develop a real software basically did not work. These spreadsheets, models, they live in different forms. I visited a salmon smoke farm in Chile a couple of years ago. I walk in there, I look at their computer, they have a model there, all programmed, and I look and say, where it comes from model? And they tell me it was Dan Stetchy from Cobourg, Ontario that gave us this model, something. Well, I gave the spreadsheet to Dan Stetchy. So these models are actually living in the computers of various ventures around the world. Kees de Lang, I worked with Kees for many years actually, trying to translate his pig nutrient flow model into fish model. And we tried and we tried and we tried, and in the end, we basically abandoned. We did some good stuff, but the things were not working. I was involved in a number of efforts trying to get funding to develop what I call a continuous improvement framework for aquaculture. And I tried to apply to so many different things and I always got rejected, even at the LOI level. So it's been a history of close to 30 years, 20 years of basically trying to develop things, doing good stuff, but in the end, all this. Now, what I've learned from academic effort is that it's actually a lot of fun, and it's a safe and great way and slow way to explore ideas, develop cutting edge science, and acquire insights and gain credibility on the world stage. It's also an excellent avenue to find, train, and get to know high quality personnel. And I'm putting an asterisk because the second part of this presentation is introducing you with some of those high quality personnel that I've worked with and still work with. It's no string attached, so industry partners sometimes trust you more. They can send you data because you're not going to compete with them. And this is great because I got invited to 4 corners of the world to showcase my work. So fly all over the world to present the modeling work. So that was great. The problem is, as an academic effort, students and postdoc, they leave and they move on. And then they go away with the spreadsheet, the data, the know-how, and some things. You're always stuck with saying, what did I do? The other major thing I see is that there's very limited return on investment for Ontario. And that might only be specific for aquaculture because we have such a small aquaculture industry. We cannot hire the people we train. But my students go to Singapore and China and Brazil and Chile and even the Canadian students go on the East Coast and West Coast and never stay in Ontario. I hire more students to graduate than probably the entire aquaculture industry does in Ontario, or at least aquaculture nutrition industry. It's complicated to find and sustain funding. It's always piecemeal. And when you want to finish something, good luck in finding funding because you already got funding to develop it. So when did you develop it? It's difficult to hire and retain a technically competent team. You cannot just do stuff with graduate students. You need programmers. You need people with field expertise. And in the end, it feels like Groundhog Day where you wake up every day and you seem to be doing the same thing. And like I said, you find spreadsheets, you say, oh, I did this 10 years ago. I forgot about it. Look at what I found, right? When the snow melted in my backyard. Then finding partners, you need industry partners and they're hard to find and hard to keep. And who blames them? What's in it for them? They send money and then what did they get in return? They get a model that you publish in a paper. So, well, thank you very much. I can read the paper for myself. And then something we underestimate is legal liability issues that actually can be quite a problem. And I got data. I sent the students collect data in the field in Indonesia. And actually we published, or we did a scientific presentation, and the company just a few minutes before the presentation get all upset because we're using the data in a modeling exercise. And I say, well, we went to collect the data, so you help us, go visit farms to collect data, but it's not your data. Our data, but actually people can actually make life quite complicated for you. The final thing I want to say is unless you put a tool, you put something real in people's hand, they don't get it. And I've gone around the world and I've helped people and I did presentation, and sometimes it's presenting like with people like deers in a headlight. They don't understand what you're talking about until you put a tool in their hand. So a scientific paper does not cut it. It's helpful, it's valuable, it's good for promotions and this, but actually it doesn't cut it. You have to go sit beside a person or give them a tool in their hand. So we decide to walk the talk, right? Need a purpose. Say, well, actually, why am I doing this? I believe in what I'm doing. I believe in sustainable aquaculture. I believe in translating research results in reality, but this cannot be a piecemeal. It has to be perennial. If I want it to be perennial and have a purpose, I need a team. If I want a team, I need money. If you talk about money, you need management. And if you talk about management, you need structure, you need this. So the solution, and I taught long about it. We try to keep it as academic as possible for many years. But a selfish, self-sustaining, well-managed corporation, meeting a global need, turning research into reality, accessing non-traditional funding source like capital investments from different things, and providing employment opportunities and keeping the benefit here in Ontario, not in Singapore, not in PEI, not in BC, not in China, but here in southwestern Ontario. That's why around 2010, 2012, I started really thinking, says how we're going to do that and associate the lab with different venture. First was various aquatic technologies. A couple of friends that people from the industry I knew say, let's create a company. Then some young guys approached me and they were actually developing a software and says, well, what a surprise, right? I'm working on this. Here's a bunch of paper, right? Go in and knock yourself silly, understanding the science, and I can help you. These two first effort fail because of problem management, because of problem of directions, or being too early in the cycle, right? 20 years into it, but it's still too early in the cycle. The last effort is called Witaya Aqua International, and I created this company together with Evan All. So Evan was graduating from MBA, was a fish biologist by training, was looking for a new venture. So we team up together and created a company to basically support sustainable aquaculture and turn this. The bigger idea as we developed it is says, well, a manufacturer buy feed ingredients from different sources. They actually track the quality of these ingredients, but this is tracked using hodgepodge manner. They use this information in their feed formulation program. They manufacture the feed, they ship the feed to farms, but then they need to know how well their feed is doing. Farms, on the other end, are buying feed from feed manufacturers, and they need to know which feed are doing best and what feed to buy and how much to feed and what select is. And this information, all this cycle, should be feeding back into the feed formulation program or the nutritional guidelines for these fish. But it's actually very difficult. You can do something very well within a company, track the use of ingredients and all this. But as soon as you get out from a company and you have clients and you have partners, it's very difficult to track the information. Add to this that the fact that you have to report to certification bodies that certify your product, BAP, ASC, Global Gap, and organic certification and the like, they require paper trail from you. They require metrics for you. You have to go get data from, if you're a fish manufacturer, you have to get data from your feed manufacturer. What ingredient did you use? What level? What was it? What kind of ingredient was? So it actually becomes a real nightmare to track this. And actually, there's lots of fraud. There's lots of stuff done on the corner of the desk and quite a lot of fraud. So we assembled this team, Evan and all, and we feel a bit like the Mission Impossible, where you open up your folder and you pick up who's going to be good. And that was the case for me. So I opened up my folder and I had Flavia Damasceno just graduates. We hire Flavia. Put up the folder. We have Neda just graduate. We hire Neda. Matthew just graduated and we hire Matthew. And Steve Gunter was a graduate from my lab many years ago. And he came back to Canada and he says, I'm looking for a job. I say, well, we're looking for people. So we're kind of the Mission Impossible people and doing great stuff. So I'll leave it to Steve now to take over because he's on the line. Oops. And I don't know how to share to Steve with Steve, but yeah, good.
Okay. Hi, everybody.
Sorry.
If you've been around at Guelph a long time, like Don said, probably 20 years, some remember me. And for those of you who don't, pleased to meet you. I'm going to try and explain what my role is in Witaya and this whole modeling of nutrition for fish. So you go to the next slide, Don, please. So prior to 98, I was full on outdoors. I was finishing my BSc in wildlife and habitat ecology, and I was as happy as a non-production animal in its own filth could be. I was out in the woods, I was chasing bears, I was going all over North America, really, really happy. I didn't have any idea what I was going to do with my degree, but I was pretty sure I wanted to work outside in nature. And then I got a summer job at the Fish Nutrition Lab at Guelph with Dom. Most of the work was entertaining, feeding fish, helping maintain the fish lab, even repairing eternally broken bomb calorimeters, and also being reminded all the time by Dr. Cho. If you could go to the next slide, Dom, I guess. Yeah. Being reminded by Dr. Cho that students and soldiers are not human beings, and this is something he used to remind us all the time, that basically we were there to work. And it was a pleasure to work with Dr. Cho. In 2000, after graduating from Laurentian and while looking for a career in ecology, I returned to work in the fish lab again, and this was to help Dom rebuild the lab. We had to tear down the entire lab. I got the nickname Pit Pony because I was basically knee deep in biofilters, digging out gravel all day. But I needed a job. I needed something to do. Dom saw some potential in me, I guess, and tried to convince me to do a master's. And I turned him down at first. I said I didn't want to do it. I wanted to work in ecology. But Dom basically said to me that if you want to understand an organism, you have to know how it converts nutrients and how it grows. And Dom is actually a pretty good salesperson. He's got a good sales pitch, does Dom. So I started my MSc, and that was with Dom in the fish nutrition lab in around 2000. So Fish Nutrition, this book here on the top left corner by Harver and Hardy, was one of the Bibles that we had copies of in the lab. And I'm not sure I read the whole book, but I had to read one chapter in particular, and that was bioenergetics. And that's the chapter that was written by Cho and Bureau. So it was mandatory reading in the lab. But the models and concepts for measuring digestibility in fish and understanding nutrient deposition that were presented in that chapter, they would prove to be incredibly important, and not just for my degree, but it turns out for my future. So my thesis, which was about patterns of growth and nutrient deposition in trout at different water temperatures, it wasn't a massive lesson in advanced nutrition modeling, but it was based on those solid concepts that were presented in this Bible, and the concepts that were developed at Guelph that Dom and Dr. Cho had been developing over the years. And then, so during my time at Guelph, I also contributed to published works on the computation of waste outputs in aquaculture, and that was using those early versions of the Fish Perfect model to collate data and build predictive models that were biologically relevant. Next slide, Dom, please. So in the fall of 2005, blinded by love and ready for adventure, I moved to Chile to be with my future wife. She was also a Guelph grad. Some of you know her. And I started working in an R&D center in a newly established to provide services to the second largest salmon industry in the world. If you can, next slide, Dom, pop up, thanks. So at the time, although the Chilean industry was producing about 600,000 tons of salmon a year, Chile was ranked near the bottom in terms of industrial-related R&D and academics. This wasn't really surprising. There were many universities offering animal nutrition degree or animal science degrees with nutrition programs, but they were all for terrestrial animals, and it was all geared towards veterinary sciences. So there was a real lacking in any material related to aquaculture nutrition. And as such, there was no aquaculture nutritionists in Chile, except for maybe a few that were working in the feed company. So the industry was heavily founded on veterinary sciences and terrestrial animal science. So Chile needed to prove itself academically, and the industry was an untapped resource. It was an untapped source of data. There was a dream for R&D, but with a lack of sound fundamentals upon which to build, it wasn't clear how to move forward. So despite very good relationships with academia and researchers from other salmon producing regions, Norway, Canada, there was a cultural need to go it alone. Chileans have this need to prove to do their work and prove themselves as an industry that we're building our own industry. We're building our own academic models. And it was very frustrating to be part of a research effort that tried over and over again to reinvent the wheel, and rather than building on what others were doing around the world. So it wasn't very good from that standpoint. So I was getting really frustrated really quickly. Thankfully, in late 2005, I received an email from Dom that simply said FYI. It just came across my desk, FYI. And I read the email, and it was from the technical director of one of the largest salmon farming companies in Chile, Aqua Chile. And he was looking for a Guelph alumnus. He basically said to Dom, is there anybody from your lab, past or present, that would be interested in getting on a plane, moving to Chile to become the nutrition manager? And it turns out that Roger also had who was the technical director, also had a copy of the Bible and wanted to work with somebody who understood bioenergetics and had worked with the author, with Dom or with Dr. Cho. This was great. I was moving to a great industry job in a place where all the cutting edge R&D happens, and I was going to get a chance to see inside this mythical black box. So I quickly found that the black box is not black. It's black because it's hiding things from you, but it's not hiding anything you really want any trade secrets. There's nothing going on inside the black box, and that's why it's black, to keep everybody out. So the industry has a lot of data. This is one of the first things I learned, like a lot of data, but few people, including us at Aqua Chile, were making good use of it. Now, the picture in the middle there actually looks like Roger. Roger is he's bald. He looks just like that, but it's not Roger. It's not a photo of my boss. But he spent almost every day sitting in front of a few less monitors, but sitting in front of data from thousands and thousands of tons of production, 50 or more sites in Aqua Chile, and he would just plot parameters. He would be plotting this against that and that against this and graphing with Excel. And it would just be looking for correlations that made sense to explain why the fish weren't performing well in a certain site or were performing well, or why the feed wasn't doing well. And then he'd try and make decisions on this with the management. And it was amazing to watch him go, but none of it made biological sense. A lot of it was just, how good is the R squared? Oh, the R squared is fantastic. So this is the one that actually makes sense, and this is what we're doing. So it was another sign that the basics were missing. And another big part of the problem was the heavy reliance on massive, the industry uses massive ERP type production management software. They're all over the place. Some of you may have heard of some of them, but they're absolutely massive. Most of them are designed as a combination of finance and production management software. So they do everything. But they're really good at capturing data, but they're not built on the back of any sound biological science methodology. So you can get a lot of data from them, but then you need a degree in data science to extract the data from them. And then you end up putting it all in Excel and doing what Roger does, which is sit in front of thousands and thousands and thousands of pages of data to try and make any real world biological sense out of it. In my role, and so looking at this energy flow diagram at the top, I was not involved in the production data, and I was looking at controlling the feed that the companies were supplying to us and these nutritional strategies that they were supplying. This was a struggle at first because, well, I was that guy. I was the foreigner. I was the one person in the industry that did have an education in animal nutrition and fish nutrition. And so on the one hand, I came with a really good reputation. And on the other hand, and people wanted to hear my opinion, but on the other hand, I was asking questions that they hadn't been challenged with before. And they don't like that. Feed companies don't like it when you challenge them because they've got this great black box and we know everything and we're just going to sell you the feed. But the black box that they were selling also wasn't supplied with such great secrets as you might expect from a company with a multi-million-dollar budget. So while the bioenergetics model on the top right that we're quite all familiar with is something that I'd been trained to use and was being adapted at Guelph. So the same Dom and his team were adapting this model and further building on it. The industry wasn't. The salmon industry, this multi-million-dollar industry, was still modeling growth and nutrient deposition on a gross nutrient basis, maybe digestible energy, digestible protein, but not doing anything with amino acids, not doing anything with the kind of energetic work that you do in poultry and swine with metabolizable energy, net energy. The modeling was really basic. So the feed companies had the fundamentals, but being a commercial enterprise, the priorities were selling feeds that would solve the issues of the day for the clients, and this was mostly disease. So these feeds relied heavily on the black box that was filled with magic bullets and not on nutritional or novel nutritional concepts that they were all building. Next slide, Dom, please. So in 2007, a virus outbreak hit the ISA virus, which is the infectious salmon anemia virus, hit the Chilean industry, reducing the industry by 50%. And in 2009, together with thousands of other people, I lost my job. But thankfully, the nutrition foundation that I had from Guelph and 3 years of high intensity training in the salmon industry allowed me to quickly find work, albeit on land. And I moved to a company that was formulating concentrate premixes for the dairy, swine, and poultry industry. But I became their technical manager and was formulating now feeds for swine and poultry. And again, the fundamentals of the nutrition I found out were transversal. So what I'd learned in my education at Guelph was transversal. Monogastric nutrition is monogastric nutrition. But I also was standing on the shoulders of giants again, and pretty much all my clients would be happy to know that I was trained at Guelph. And the poultry farmers surprised me. The first poultry meeting I had, like, so where are you from? I'm from Guelph. Oh, how's Steve Leeson doing? And it's like Steve Leeson had been everywhere in Chile, and everybody knew him. So it was a great way for me to name drop and get my foot in the door. I had a good relationship with Steve Leeson, who was on my committee at the time. Terrestrial production was interesting. The dynamics of formulating feed on a metabolizable energy, net energy basis, or to levels of digestible amino acids and mineral balances that I'd never done before was a challenge, but it also left me questioning, why are we not doing something better in aquaculture? Surely with what we spend on R&D, which is millions, cutting edge R&D centers around the world, why are we not doing this? Well, partially it's contributed to the industry having bigger fish to fry and different commercial focus. Much of the global R&D effort was and still is today focused on feeds that help combat disease. Functional feeds command more profit in the industry. It's as simple as that. It's a money game. Next slide, Dom. So in 2012, the salmon industry had recovered and a return to aquaculture. So Nutrial was a company that hired me to manage their aquaculture business. And they were a feed additive distribution company. And this is where my path took a turn, and I was spending much more time with feed additives. The challenge in this role was trying to quantify the extra value that products and functional ingredients and commodities could bring to feed manufacturers. So how do I compete with all of the other competitors in this field and show a feed factory that tiny little bit of methionine, which is chelated to zinc, has more, means that product has more value? How do I quantify that? I can do it on paper, but then how do I do it in the field? Could I get the production data necessary to be able to do that? And then because of this massive undertaking of the data that's not available or is really complicated to extract from the aquaculture industry, I couldn't do it. So I was married to a family of entrepreneurs, and it was only natural that one day I would start my own company. And Practical was my own feed additive company. I started in 2014 a feed additive company and had no shortage of feed additive suppliers that wanted me to sell their magic bullets into the lucrative salmon industry. Ironically, again, I ended up selling and building stronger relationships in the dairy industry. And I knew nothing about dairy, knew nothing about these animals with 4 stomachs and how nutrients flow through those, apart from a few advanced nutrition courses at Guelph. But again, those kind of fundamentals and the context I had at Guelph allowed me to name drop again to get into the door. And it was another lesson, but this was an important lesson for me on how advanced the nutritional sciences were in the dairy industry compared to, they were monitoring what was going on in individual animals and modeling milk production based on nutrients. And to make decisions, to make every decision. And surely, again, the aquaculture industry could learn something new from this industry. In 2017, after 12 years in Chile and a separation, I took the opportunity to move back home to the UK, where I'm originally from, and I took up the technical director's role in Biomar. This was an amazing opportunity and felt like my natural progression from production through feed ingredient supply to the companies that were making the feed. But this role was the real one that was about data management and the constant need to rapidly access data, to collate it, process it in a high pressure business and make decisions rapidly. The UK facility I was working at was at maximum capacity, producing 110,000 tons a year. And they were running 24 hours a day, 365 days a year. So there was no time for mistakes. Every failed ton was money down the drain and delayed production further. So as the technical director, I was responsible for QC, QA, formulation, implementation of R&D, problem solving, feed quality issues, failed feed, an enormous list of tasks I had to do, but I needed data to make the decisions. Constantly frustrated because every single link in the chain that had data for me used Excel to manage data. And I know you're thinking that in these multi-million-dollar companies, surely they've got big data management systems to take care of all that. Well, they do. But again, they're these complicated ERP systems that manage most of the daily life and all the information from finances through to production. But you also then need to patch it with a new ERP or a new system so that PLC that controls the factory can talk to this system, then a patch to extract the data. And in the end, it's no surprise that every single person falls back to Excel. It's safe, it's simple, everybody knows how to use it. The problem is everybody uses Excel differently. And it was a nightmare to make decisions based on Excel. So I got frustrated with that job, and when I was having some personal issues and decided it was time to move back to Canada. So in 2019, it was finally time for me to come home. And I asked Dom, I reached out to Dom before I moved, and I said, Dom, do you know anybody in the aquaculture industry that's hiring? And turns out Witaya was hiring. So and I got to Witaya and I talked to the CEO, Dom's partner, and they were doing some really great stuff. They were making this simple production management software platform that I knew had potential based on everywhere that I'd been. It had some tweaks and stuff that it needed to do. And one of the other reasons that it was really interesting to me is because I spoke Spanish. So the whole the whole continent of South America was kind of going to be my domain. So that was a really interesting prospect for me. But what they needed and what they lacked was industrial insight. They didn't have anybody that had been in all of this part of the chain. And also, thanks to where I'd been and that damn book, the fundamentals that I had in it, I kind of understood what the industry needed. I kind of understood what Dom and his team were trying to do and where it fit. Next slide, Dom. And that's where we are now. So we've developed, which I have been developing this cloud platform. We've got 2 platforms, AquaFeed and AquaFarm. And I've been part of this great team that's been developing this fantastic platform. And if you go to the next slide, Dom, this is back to Dom's slide that he presented a few slides back, but now you can see where we've gone with it. I was originally tasked with working on the AquaFarm down in the bottom in the center there, and getting that out to farmers around the world and in Latin America. But over the past year, and we clear a holistic view on what the entire supply chain needed, Witaya now has developed this whole suite of tools that tie together the incredible amounts of data associated with raw material supply, true ingredient value, feed formulation and raw material use and traceability, how the nutritional requirements of this multitude of species that people are farming around the world, how to build the proper growth and feed prediction models, real-time performance benchmarking that allows this whole industry to work together to make better business decisions. And now Neda and Flavia and Matthew are going to demonstrate how these platforms, individual platforms, are built on the back of solid nutrition and the science and data analytics that Dom's team has been doing for 20 or 30 years.
Okay, hello everyone. My name is Neda, and I'm going to give a little bit background about myself for those who don't know me. I got my master degree, the first master degree in animal nutrition. Basically, it was ruminant nutrition. And then I got my second master degree in feed manufacturing technology, which my master project was on developing a feed for aquatic animal. So there I got interested in continuing to learn about aquaculture nutrition, and I decided to do my PhD in aquaculture nutrition. So I did my PhD in aquaculture nutrition in the University of Guelph in Animal Biosciences Department and in Fish Nutrition Research Lab with Professor Dominic Bureau. And my project was to develop a model that predicts nutrient requirement of fish over their commercial life cycle. And for that, I learned a lot of skills in data analysis and also modeling skills during my PhD program. And after I graduated, which was exactly 1 year ago, I officially got joined to Witaya Aqua science team, so I could apply the skills and the experience that I got in during my PhD program and master programs, actually use it in practice. Next slide, please. So one of the projects that I'm working on in Witaya Aqua is directly related to the thesis that I had for my PhD project, which is developing nutrient requirement model. This model, so I contributed to developing this model, which is basically giving a nutritional specification for commercial feed for over 30 species. And these information is available online for free in IAFFD website, International Aquaculture Feed Formulation Database website. And also a part of it is available there. And also we're using this information in our feed formulation tool, which a colleague of mine has developed. And the model behind it is basically based on a very advanced modeling approach that we have developed, which allows us to modify nutritional requirement or nutritional specification of feed for fish at different commercial life cycles, and also at different production systems, for example, intensive, semi-intensive, recirculating aquaculture system. So it's very flexible and got very advanced approach that we're taking in this project. Next slide, please. The skills that I have learned in the Fish Nutrition Research Lab was basically based on many years of scientific work and like a lot of advanced work that has been done in Fish Nutrition Research Lab. And I had the opportunity to learn these skills and contribute to developing them further. And So these models that we have developed in Fish Nutrition Research Lab, now they're very advanced, and we can use them and predict. For example, some of these models are like the growth models that predict the growth trajectory of animal, or the bioenergetic based model that we are using to predict feed requirement of animal. So right now we're at the stage that these models are giving us a very good prediction with high accuracy. For example, in these two graphs, you can see these are data from one of the largest salmon producing farms in the world, and you can see that our prediction is very close to data from farms. So it gives us a prediction with a very good accuracy. Next slide, please. So these models, we are using these models in one of the software that we have developed in Vitaya Aqua, which is being called Aqua Farm. And this is basically a farm management software. And in these two screenshots, you can see that the farm is giving production forecasting based on the growth model, advanced growth models that we have developed in Vitaya Aqua. And also it is giving estimates feed requirement of fish based on fish species, temperature, type of feed, composition of feed. So there are several variables that the farmer can add and regulate, adjust the model and the output of the model based on that. And it's pretty very useful and very practical that we are actually have developed based on the science that we have developed in Fish Nutrition Research Lab. Yes, next slide. Yeah, so basically Aqua Farm is, as I said, a farm management software, which other than just giving growth curve and like production forecasting or feed requirement of the animal, it is also giving a lot of information to the farmers, and also allows the farmer to keep track of their information, like not to have to use multiple spreadsheets, put all the information, like have their information all over the place in different spreadsheets. So they can put all the information that they have from the farm in one software. They can keep track of it. This software is visualizing this information, makes some predictions, makes some calculations, gives information on water quality, so, and does some predictions. So basically quite very advanced software that we have developed, and we are using this knowledge and skills of modeling that we have developed in Fish Nutrition Research Lab actually in practice and industry. Yeah.
Hello. So some of you might see me around the department, and for those who didn't, it's a pleasure meeting you. My name is Flávia Damasceno, and I'm a aquaculture nutritionist and modeler with Aqua since mid-2019. So just talking a little bit about my background, I have a bachelor degree in animal science at the University of São Paulo State in Brazil, the same place where I did my master's in animal nutrition. And then in fall of 2014, I moved to Canada, and I started my PhD with them at the Fish Nutrition Research Lab. And I can say that where I started getting more familiar with mathematical modeling. Honestly, I can say that my first experience with modeling was when I took a John Scott graduate course. And at that point, I didn't know that I had the background necessary for doing modeling, but all I need to do was learning how to use it. And I did it for my PhD thesis. So I used the dynamic model in my first 2 chapters to examine the dynamic of digestion of different chemical forms of phosphorus in fish. And then in my last chapter, I used a path analysis approach to examine the effect of gastric pH in the phosphorus digestion. So having all this background in modeling, it opened the doors for me at Vitaya Aqua, where I started working with them right after getting my PhD degree. Don't, next slide, please. So at Vitaya Aqua, I've been involved in several projects, and one of them is a set of tools that we developed for the aquaculture feed industry called Aqua Feed. So this is a platform that focuses on helping feed manufacturers and supporting them in making better decisions around the formulation, ingredient choice, and market opportunities. So I'm going to give a brief overview of what it entails here, and it has 3 main pillars. So the first tool that we developed is a raw material map. This tool basically serves as an internal feed library or databases which The feed manufacturers can capture the information and use it to benchmark suppliers or establish or measure quality assurance, quality control benchmarks, and a multitude of other things. The second tool is what we call economic evaluation tool. And this helps raw material suppliers and the feed industry to evaluate the value of raw materials in a more holistic way than simply price sharing. So it takes the nutrition, but it also takes other key attributes, like if the ingredient is a no GMO, if it's organic ingredient, for example. And then finally, we have the feed formulation tool, which allows the user to formulate feeds out of the box for many species, but it's not just a simple feed formulation tool because it also provides some additional functionality and features around running feed formulation scenarios for different species in different countries. And it's also being able to evaluate the size of new markets, whether within your country or within countries through the world. Next slide, please. So this is a snapshot of the raw material mapping tool. So here the user can see, let's say I'm a feed miller, I can see all the information of the ingredient that I have, that I selected. So this is an example of fish meal. So I have all the general information of the ingredient. I have the historical information. I have the information from recent shipments. And I can also add batches of this ingredient specific. So I have the specifications that the supplier gave me. And if I send this ingredient to a lab, I can put the results of the lab of this ingredient here. And this tool helps feed manufacturer to track the quality of the ingredients they're purchasing and also compare, let's say they have fish meal from 2 different sources, so they can compare the quality of these 2 fish meals, and they also can compare the historical price of the fish meals or any other ingredient they are looking into. Moving on to the second tool, which is the economic evaluation tool. So here I can say that is the tool that I could apply more all the modeling background that I have during my PhD. So the economic evaluation tool, it's based on a advanced statistical analysis technique, and it relates the nutrient and current market prices of feed ingredients in 14 country-specific databases. So this model that we use for the economic evaluation tool was based on a dairy feed stuff by Professor Normand St-Pierre at the University, Ohio State University. And we kind of like expand the model where we include some attributes. I'm gonna cover what these attributes mean in a moment. So the economic evaluation tool enables to estimate the economic value of ingredients. For example, the value of the digestible protein of the ingredient, and also certain attributes that the market is willing to pay for. Next slide, please. So the aqua feed has a large databases, has 14 countries. So far we have 14 countries. So we, the nutritional team at Aqua, we search for all the ingredients that are commonly used in aqua feed in these all 14 countries and the current market price of these ingredients. So we use these databases for either the economic evaluation tool and the feed formulation tool. And in the economic evaluation tool, we use over 20 nutritional parameters and 13 attributes to estimate the economic value of ingredient. And we are continuously evolving to better estimate our predictions. So here's the list of the nutritional parameters and attributes that we have the economic evaluation tool. So we have this small table on the left corner, which are the attributes that I mentioned. So these are basically characteristics that the ingredient have that the market's willing to pay more for it, or maybe it can have kind of a deduction in the price. So for example, a fish meal is an ingredient that is high valuable, and the market usually pays more than what the nutritional value of the ingredient is, just because it's a marine protein source. So if we don't account for that attribute, we might be underestimating the price of a fish meal, for example. So we have a terrestrial protein, GMO, no GMO, if the market it's willing, like it's doing organic feed, so we have to count for organic ingredient as well. So the beauty of our model is that we are not estimating the feed only based on the nutritional value, but all the attributes that the market is willing to pay. And we also have all the nutritional parameters that we have in the model. So obviously, those attributes and nutritional parameters changes between markets. Next slide, please. So this is just an output of the economic valuation tool. This is an example for Indonesia. So you have the list of ingredients, the current market prices, and the model estimate what is the economic value of the ingredient with and without the attributes. So we can see the first ingredient is a blood cell meal. The market price is $820 per ton. The economic value that our tool estimated is 700 with the attribute, but without the attribute, it could cost 900. So in this case, in Indonesia, the land animal protein, which is the case for this blood cell meal, has a deduction in the price. So we have this table here in the right corner where it gives the estimate cost of nutrient in index per tons of what the market is paying, it's willing to pay for each one of the attributes in the nutritional composition of the ingredients. And we have this graph on the right corner, which it helps to visualize the price distribution. So depending on the buyer perspective, it's let's say I'm a raw material supplier, I'm selling a fish meal, and I'm selling my fish meal. My price is above the line. It means that I'm doing a very good deal because I'm selling my ingredient more than what is worth it. If my ingredient is being sold below the line, the red dots, it's mean that I'm doing a bad deal because my ingredient should it worth more. Next.
Okay, thank you, Flavia. Hi, everyone. I'm Matthew, and I'm one of the agriculture nutritionists at Witara Aqua. I actually just graduated not too long ago from Guelph, just last summer. And then once I graduated, Dom took me into Witara Aqua. So in Witara Aqua, the majority of my work revolved around feed formulation, the review, modeling, data management, which are the skills that I learned during my MSc in the department. And I also facilitate the transfer of knowledge, scientific knowledge, nutritional knowledge, modeling work into flowchart or pseudocode so that the software team can understand. And I'm glad to come back here today and present to you a little bit about the future that we're building at Witara Aqua. Next slide, please. Yep. So let's take a look at this diagram. As you can see, there's a lot going on here. A fish pond is a complex and highly dynamic environment. We are currently expanding our work in Witara Aqua to take into account the very complex processes that are going on in the culture environment, like a fish pond presented here. Through the combination of the estimates from models and actual field measures, we're confident that we can develop a much more greater understanding of the factors that influence the productivity and the environmental impacts of different types of waste, improve the efficiency and sustainability of the fish culture. And in order to achieve these, Witara Aqua developed a software called AquaHub, like we presented, that allows for allow aquaculture nutritionists and farmers to have access to the power of models and help them manage their fish and shrimp culture operations. Next slide, please. So if you take a look, conventionally, farmers, nutritionists, and feed technician would observe the population from above, and this is what we call the top-down approach. And traditional modeling would fit the decrease in population into the model, but this would introduce a lot of errors into because a fish or a shrimp pond is a highly dynamic environment. Not only there are fish-to-fish interaction, there's also fish-to-environmental interaction, and having a simple prediction curve like this without considering any other factors doesn't really make sense. So instead of just fitting the decrease in population, we look at the population from a different perspective. From my master's study, I looked into a modeling approach called the individual-based modeling, where I modeled the response of individual animals and some of their responses to different factors or stimuli in their environment to produce an estimation of the population. And we call this the bottom-up approach, where every individual is a building block of a population, and the prevailing condition of the environment, such as ammonia or dissolved oxygen concentration, will affect and determine the probability of survival of that animal. This will allow for a more dynamic estimation of the population. we want to introduce the principle of artificial intelligence into our bottom-up approach. So using AI to predict the decision-making process in individual animals, such as movement and feeding behavior, etc. And really, in the future, Retire Aqua wants to incorporate AI into our services and products. So we want to help sustainable farming practices by reducing feed waste, prevention of disease through monitoring, price tracking of feed ingredients, and ultimately supporting the decision-making on the farm management level. The science team is working hard to improve our existing models and learning more about artificial intelligence and how we can incorporate AI, machine learning into these ideas and unlock the potential of farm data.
You're on mute, Tom. You're on mute, Tom.
My apologies. So I'm trying to gain back. Right. So just a final slide to kind of cap off. I know I'm in academics and working in partnership with industry, but I have a guiding kind of a long-term dream. And I was inspired by the dairy genetic evaluation research that we've done in Guelph, but in partnership with the industry. That has been central for creating a whole ecosystem around Guelph and everywhere in Canada, but especially around Guelph with CMEX, Canadian Dairy Network, now called Lactanet, and all the tools, CanWest DHI and all this. And all of this started with a collection of farm data, the analyses and these data and the academic research that was done at Agriculture Canada and in our own building in the basement of the animal science nutrition building by members, the early member of CGIL stuff. So I have this dream of creating this ecosystem back in Guelph where it's not dairy, it's global, it's aquaculture, but it's global aquaculture because Canadian aquaculture is small, but we can bring through the use of these tools, collection of data, we can create an ecosystem around Guelph, around southwestern Ontario that collects, analyzes these data. There's a number of industry players around the Guelph region. Flonergia was created by Wael Ahmed from the School of Engineering, for example. There's a company in Kitchener called Deep Trekker who's producing underwater submersible rovers. There's a new lab, a new company in University of Water called Blue Lion Labs. We're doing water quality probes. So we can actually create this new kind of ecosystem in Guelph and all this, where it's a partnership between industry and this. I thank you very much, and I thank all my my co-presenter here for the talk today. If you want to learn more about our efforts, the modeling and all this, send me an email. If you want to demo the platform, just send an email to Retire Aqua, and Steve and our colleagues are going to be happy to give you a walk through all the platforms. Thank you very much for the opportunity.
Thanks, Dom. That was a great talk. I think you've set the bar pretty high for our reboot of our nutrition seminar series. So Kate says thank you because she's going in February. Any questions? You guys can type them into the chat, or you can put up your hand button, or you can unmute yourself and go ahead and ask a question if you have one. Any questions?
Well, I have a question to start. Yeah, that's very impressive. Such a broad vision you guys have of putting all this together. And it reminds me a little bit of when Cornell was developing what we call the Cornell model now for dairy and all the different activities. Yours is much broader, more comprehensive than theirs was. But so my question is, who are the users of it? So I'm not sure how, the nutrition business is really structured in aquaculture. And so feed manufacturers you've talked about, are there nutrition consultants? So are there individuals who are using it? Do farm operators use it? Is that the intent, or what's going on there with the users?
The first users that are really adopted is the feed ingredient suppliers, because aquaculture is a growing field, it's a new field, so a lot of new ingredients from the insects to the fermented single cells and all this. So actually, they approach us to run simulations on this. Even big oilseed producer or corn processors are also starting to use the platform and asking this. It's funny because they want the tailored services. They want like the hand holding, and the company is developing these software for you to be able to use it just for right a few $100s per month, or even less than this. You can actually access this at your fingertip, but a lot of companies still wants the hand holding, so that's why a big part of the work is holding them. So feed ingredient suppliers, we have feed manufacturers are interested, and aquaculture farms that are using the AquaHub Farm platform, and integrators also great. Aqua Chile is one of our clients, and they're like they use it from ingredients to feed to production management, like Meta showed.
Cool.
Maybe I can ask another question. John and I have had talks in the last 6 months or so, and we had a big CNM kind of rethink tank just a year and a half ago, I guess. And making models more accessible is kind of one of our ideas going forward. So based on kind of taking your science and developing the interface and actually getting it applied in the field, what kind of sage advice would you give us in terms of taking that step and making our models more accessible, I guess?
Find a great team. Find the dream team to work with. Actually, I mean, if it's a commercial, if you want to, I would recommend establish a commercial effort, because you can access resources that are not available to this. Keep your strong activity in academy, but create a side show, I guess, all this, and you need effective management. That's been the hardest part, is finding an effective partner that can manage that business and keep all the ducks in a row on the accounting and the reporting and all this. So that's really the most challenging part of it, and that's why I think we didn't go very far with the academic effort. It's just so complicated. It's out of our pay grade or toolbox, right, to manage all, like, at least it is out of mind. So that would be one of the advice.
If I could give another one, is you really need to be in touch with the needs of your target customers. As you start developing software, and these kind of applications, you've got all this thing in your head about this is what they need. This is what they need, and then it turns out that might not be what they need. But so, I mean, you always need to have those conversations with the industry ongoing, to be kind of like, what is it you want out of a model or a piece of software that we might be able to put together for you, but also not to have your own assumptions be the hiccup that doesn't get it into the commercial scene. Like, just get it out there. I mean, like, don't keep trying to develop it, get it perfect, because what's perfect for you might not be perfect for the next guy. So get a version that's practical, works well, and is simple to use and looks good, and then keep developing based on feedback. But you can't. Our CEO Evan has this thing that a lot of investors will say that, unless you've been embarrassed by the first thing you put out there commercially, you've taken too long to put it out there commercially. So that's one of the sage kind of things. Like, don't try and get it perfect at the beginning. Like, just get something working and out there.
Yeah, nice. From the comments, Dan said, great presentation. Sorry, he had to leave for another one. Jim asked, do you have any advice for anyone that plans to develop a commercial company? How do you balance your responsibilities to both your academic and commercial roles?
Yeah. Hi, Jim. It's hard to balance, but at some point it has to be done. You have to balance your involvements. You try to train a team that can take over the work. And initially, I mean, we've had all young graduate, and they're learning very fast and establishing themselves. So hopefully they learn how to ride the bicycle, right, by themselves, and you can let them go, right? Take off the four wheel and the two small wheel on the bicycles, and they can go on their own. So that means coach your team. Like I say, get a good team, coach your team, and train them, and then trust them after that. So trusting them more to do the work. That's the thing, and that's where I'm the point I am. So I was away for, I guess, a little too much for a while, but I think I have this vision. I was ever since I work on a dairy farm and I saw the dairy classification, the dairy type classification, and I saw the milk recording going on and everything. And I was in the basement of the animal science building here, and I saw Gord Vandervoot in the middle of the night doing his crunching millions of data in 1992. I says, wow, I want to do the same thing for aquaculture, and it could be here in the basement of the building. I mean, we have the computers, we have the scientists. We could be creating, somebody is interested in genetics and wants to do the same thing on the genetic side, by all means, just create your own venture, and we team up, and then we bring things, and who knows, maybe we can hire the same way we were able to attract Charlie Smith and Mike Loheis and all these right, and Jack Deckers and all the CGL people that we attracted over the years, right, were actually funded by these efforts by the dairy genetic evaluation program. So I think we can create the same thing in Guelph. Give me some time and we'll build it. So like Steve said, who says we're building a baseball field and a cornfield. So
Nice.
Do you mind if I ask a specific question?
Go for it.
Thanks for that presentation, Dom and Steve and everyone. Since I'm the other fish guy, I need to ask some more fishy questions. I was wondering, I've got two questions that are kind of specific. One being, how do you account for, it's great that you're using databases in 14 different countries, because that'll capture some of that regional differences in feed ingredients, but how do you account for, there can even be differences in protein or lipids and other nutrients just farm to farm. Is it difficult to capture that and then model that variation between farm or between batches?
well, Flavia is the expert in this. Flavia, Matthew, and Netta are the expert in this. Maybe Flavia? You're muted, Flavia. Want to answer?
Sure. Do you mean the difference between like feeds or
Feed ingredients.
Oh, feed ingredients. Yeah. So we have like our platform that was built. The ingredient composition, we use the IFFD that Nida was presenting. So we have the feed ingredient composition databases. So we have the nutritional composition of like around like over 600 ingredients, and we use that. And we also have contacts, and we like build this platforms also like based on like both the feed ingredient database and some contacts that we have in the field to capture this difference that has between countries and between farms. I don't know if I answer your question.
It is a lot of work actually to do this. Like you have let's say a soybean meal, a fish meal. Every batch is different. So actually you get data and then you have to vet and you have to correct and all this. That's a big part of it. So that's why it looks easy to say, oh, there's a least cost formulation that exists. Actually go and find a relevant database that is going to be fitting exactly that country in that specific situation. And it's a lot of work. It's actually weeks and months of work in order to get the price, the composition, everything right. So that's why it's a big part of the work.
That sounds exhausting. But yeah, really good work. And the second question was, you talked about a bias with sampling or subsampling on different farms. Do you have any recommendations for that? Like, should the farms be, I think that kind of segues to experiments as well. Should the farms be doing more passive sampling of fish on the farm? There's very advanced ways with infrared in a lot of Norwegian farms. Yeah. Or should they just be measuring all the fish, or is that even practical to do, or what do you recommend to do there?
Very hard to measure all the fish. There's technology available, these frames, there's all kinds of technology coming up. Some of them are not going to make it to market or be used, but there's some that exist. Some people say, yeah, well, we need a growth model or something because we can measure, we can put a frame in the water, we can know the size of our fish. Well, I say you can measure very precisely how much milk a dairy cow is producing and how much fat is coming out right from the udder, right? Basically with the sensors now. and still models are used. Still models are very important. So I see the technology as part of the answers, but the model is part of the answer. So actually the models allows you to see if there's any nonsense in there. That's been the best part of this modeling trip that I took, is actually I got data and says, this is nonsensical. This doesn't make any sense. And you talk to the farmers and they say, yeah, so aquacage fisheries in Parry Sound, they stop sampling in the middle of winter. It's just too dangerous and it's not worth it. The employees are not lying, but they're sampling all the bigger fish. So what's the point? So they're actually using the model to predict the weight of the fish. It's safer, save time. They can focus on what makes money more, right? Feeding the fish, managing the fish property, managing the business property. And you can go and talk to fish farmers and that have used a model, and they're going to tell you it really works and it really helps. So it's this. But I mean, modeling, maybe I'm going too far, but modeling is like your brain makes model all the time. When you're walking, your brain extend your foot, right? You extend your leg and your foot, and you know whether you're right or not when the foot hits the floor. So modeling is part of life. So, and that's a culture that we're trying to bring in the field. It says, well, you need ways of predicting things in order to see whether the reality makes sense or not, whether your planning makes sense or not. So that's all part of that. And the technology is part of that answer.
Great, thank you.
Any last questions? Okay, if not, John, do you want to wrap us up, or?
Yeah, now that we're all blown away by all this activity and go, oh, these small little things that I'm working on are nothing compared to the scope of that. So yeah, that was awesome. That was great, and it's good to see all the participants. You know, all your former students, not all of them, but I mean to see these former students coming in here and working on this. So it looks like an awesome team, for sure. So thanks very much for doing that presentation for us and kicking us off again for another season of these. And so it's Anna K. Shoveler's group is presenting next month, February. We've got a date, so keep an eye out for the invitation and the Teams link to join us. So thanks, everybody.
Thank you very much, everybody. Great.
Thanks, guys.
Thank you. Thank you very much.
Thanks.